Building an industrial wastewater plant demands a massive upfront check. A bigger challenge lies in the 20 years of operational hurdles that follow, costs and complexities that glossy sales brochures often gloss over. The market usually narrows your choices down to 3 primary technologies: MBR, MBBR, and SBR. Selecting the right one requires matching a technology's specific hardware needs to your facility's actual physical and technical limits. This decision tree maps 3 parameters: physical space, operator skill, and target CPCB quality. The zero space branch means tight footprints requiring highly purified water. The low-budget branch assumes plentiful land but lacks specialized engineers, needing minimal daily attention. Selecting a sophisticated system based on water quality alone, without accounting for your team's maintenance capacity, creates a misalignment that often leads to expensive breakdowns and regulatory fines. The membrane bioreactor, or MBR, is designed to produce high-purity water while eliminating the need for bulky settling tanks. It uses a suspended growth biological process. Bacteria float freely throughout the aeration tank, consuming organic waste as it flows through. As the cross-section shows, vertical ultrafiltration or microfiltration membrane cassettes are submerged directly into this biological mix. A suction pump pulls water through microscopic pores, completely blocking suspended solids and bacteria at the surface. The resulting water is clear enough to feed directly into advanced reverse osmosis or zero liquid discharge systems without fouling the sensitive equipment. This chart shows MBR's performance relative to CPCB limits, hitting a BOD under 5 and total suspended solids under 1 mg per liter. It achieves this premium quality while requiring 50% less physical space than conventional systems. Operating at this level requires high power consumption to keep the suction pumps and membrane aeration running continuously. While MBR offers premium water quality and a tiny footprint, it demands expensive membrane replacements and a highly skilled team to perform regular chemical cleanings. If you need a system that can handle operational neglect, the Moving Bed Biofilm Reactor, or MBBR, is the industry's most resilient option. This architecture uses an attached growth concept, giving the bacteria a fixed home rather than letting them float freely. The aeration tank is filled with thousands of small plastic media carriers, providing massive surface area for colonizing bacteria. A thick biofilm grows on these carriers, actively consuming organic waste as they continuously tumble through the water. This biofilm acts like heavy armor, allowing the bacteria to survive sudden spikes in pollution or shock loads. These toxic spikes would typically kill off or wash away the bacteria in other conventional systems. Because the bacteria are attached to media, the water must eventually flow into a large, calm secondary clarifier. Here, gravity pulls any old, dead bacteria to the bottom to be removed as sludge. MBBR easily meets standard CPCB norms, though the water isn't pure enough for direct RO recycling without adding tertiary sand and carbon filters. You trade a larger footprint for the lowest operating costs in the group and a system that can absorb significant operational errors. The sequencing batch reactor, or SBR, is a high-capacity system that completes the entire treatment cycle within a single tank. The defining difference here is that SBR is a time-based batch process, not a continuous flow. The cycle follows a strict timeline. First, the tank fills with raw sewage, and blowers pump in air to activate bacteria. In the settle step, blowers stop. The water becomes still and sludge settles, leaving clear water. Once the water is still, a motorized decanter arm lowers to the surface and skims off the clear top layer without disturbing the sludge below. After the clean water is removed, excess sludge is purged to make room for the next batch, and the entire cycle resets. SBR is particularly effective at removing nutrients like nitrogen and phosphorus because the oxygen levels can be precisely timed. This makes it a preferred choice for large municipal plants and massive residential developments. It saves the space of a separate clarifier, but it relies entirely on complex automation. If the pneumatic valves or control systems fail, a basic operator cannot easily run the plant manually. Buying an STP is about aligning a machine's mechanical requirements with your facility's actual operational bandwidth. We can map these 3 technologies to 3 real-world profiles: the recycler, the pragmatist, and the municipality. The recycler has almost no physical space, is under a mandate for zero liquid discharge, and needs to protect expensive RO systems. MBR is the recommendation for this profile. It delivers the highest water quality in the smallest possible footprint. The pragmatist has land to spare, but operates on a tight budget with a team that has only basic technical skills. For them, MBBR is the best fit. It is a set-it-and-forget-it workhorse that keeps costs low. The municipality manages huge daily volumes and strict nutrient regulations, backed by a staff of dedicated automation engineers. SBR matches this profile, providing efficient, high-capacity batch treatment that rewards skilled oversight. Avoid MBR if you cannot sustain high chemical and power costs, and avoid MBBR if your site lacks the land for clarifiers. Match the technology to your reality, not the sales brochure.